All right, so now what I'm going to do is I'm going to cover a topic called simultaneous equations. Simultaneous equations. All right? And you might have seen this, you might not have seen this. We'll see what we got. What I want to do is they're going to ask you to solve this simultaneous equations, or this solve for the solution set of these equations. And my question is, what the heck does that mean? Do you know? All right, here's what it's saying. What kind of function? Is this a linear function or is this a quadratic function? No, it's a linear function. It's a quadratic if you have an x squared in there. Right? You remember that? But if there's an x only to the first power, then it's a straight up linear function. Right? This thing describes a line. If it looks something like y equals 2x squared, then you know that that's going to describe some kind of arc, like a parabola or something. We cool? All right. So you know that this is a linear function. What about this? Is this a linear function or a quadratic function?
Linear.
It's also a linear function. These are actually two lines. So what I'm asking you to do when I say solve an equation, solve these two sets of equations, is really, if it's all right with you, I'm going to make this look a little bit differently. I'm going to make this y equals negative 2x plus 14. You should actually be more comfortable with this than this. Are you?
Yeah, a little bit.
Why? You should like this. I actually like this better than this. I'm looking at it, I'm just saying. That I'm cool with. You don't know why.
Not really.
Okay. Because this is in the form y equals mx plus b. Does that make sense? This is already the y equals mx plus b. Here's the m, here's the b.
Oh, I see.
This is the form of a line that you are very familiar with, you are very comfortable with. This right here is a little weird. This is called in standard form, and I don't like it. This is called in slope-intercept form. I like it. And all I did to do that was I took the 2x and put it on the other side and made it negative 2. Does that make sense? Make sense to you? Make sense to you, Makana?
Yeah.
All right, what about online? Are they cool? I need you guys to chat. Come on, chat back with me. And then Coco, we good?
Justin said yes.
If it's all right with you, I'm going to do two steps over here. I'm going to say, all right, well, 3y equals negative x plus 12. All right, did you see what I did there? What did I do?
You just did 3 right here. You changed the plus 2a equal sign and made positive x into negative x and the plus 12.
Yeah, I didn't necessarily change the plus to an equal sign. I kept the equal sign here. What I did was I took the x over to the other side. I just took that guy. He's plus over here. I want to subtract him. So I subtract him from both sides. That's where I get the negative x. And basically taking and pushing that x over to the other side. Because I want to get y all by itself. Right? If I'm getting the y equals mx plus b, I need y all by itself.
Yeah.
Is y all by itself?
No, you gotta get rid of 3.
How do I get rid of this times 3?
Negative 3?
Nope.
Wait.
Divide by 3. Perfect. Perfect. Now, I know that your sister's thinking, oh, good, I'm glad she's up there, and I'm not up there, because he's putting her on the spot. But you're doing great, okay? You're doing really, really good. And I know that I'm going to probably call you out on a few things, but my goal here is not to embarrass you, but to really just help you along. Okay? And it's actually good that you don't know everything, because I guarantee you that your classmates don't know everything as well. And if they don't know everything, that will kind of like your questions will help them understand it better. So feel free to ask questions and not understand. And it's my job to explain it to you correctly. Makana, can you close that door maybe about halfway? That might get rid of this glare. Okay, that helps out a little bit more, a little bit more, a little bit more, a little bit more. Stop. All right, that works better. All right, so here's what we got. How do you said divide, right? Okay, so I'm going to divide by 3, and so I have y equals negative 1/3 x plus 12. Everyone cool with that? Say yes, no, Coco, yes? Okay,
Yes.
Makana,
Yes.
Justice,
Yes.
Justice?
Yes.
Okay, awesome, awesome. And Jillian, Juliana. I don't know. All right. Yeah, Tay, just grab a chair, pull it up, close the door about maybe as far as you can get your butt in here, and then close the door as on you. Because the more you can close the door, the better the better I can see. So the glare goes away. I know. There's an iron hanging in the doorway, and it's because I'm a physics teacher. Yeah. All right, so check this out. All y'all are wrong. I'm just letting you know. I messed with all of you guys. Look, when you divide by 3, you can't just divide the x by 3. You need to divide the 12 by 3 as well. You're dividing everything on the right-hand side by 3. You're not playing fair. No, don't try to get this whole thing inside the door. The door. Just get it in as far as you can, and then close the door as much as possible. That'll be good. That's the best we can do. That's the best we can do. All right. So you need to divide this 12 by 3, and so you get 4. Are we cool with that?
What
Yes.
are you doing?
So I'm going to erase this, if that's all right with you. I'm just going to write down my answer. This was all just side work. That said y equals -1/3 x plus 4. We cool? All right.
Oh,
Now-
simultaneous equations.
Simultaneous equations. You couldn't read that backwards, could you? Yeah, but you can look on that computer screen and look at simultaneous equations. Tejas, you can stand up here next if you want, but for now I've got Coco.
Okay.
So this right here is some kind of weird looking equation, but you're familiar with these two things. And these are the same thing. And you know how to get from here to here, correct? By the way, I'm just letting you know, I already made your final exam. It's got a whole bunch of these on there. So get good at doing this kind of stuff, all right? Get good at solving for y and all of that kind of stuff. I'm just letting you know. Fair game, all right? All right, let's see. Let's graph that, just to try. Come on. All right. This thing has a slope. What is the slope of this line right here? Do you know what it is? What's the slope of this line?
2.
It's not
2x.
2. It's
2x.
not 2x. She's better off. It's not 2x.
Oh, 14.
It's not 14.
I don't know. -2x.
-2. No, not x. There's
Oh.
you don't include the x. Just
Oh.
-2. It's the number. Right. It's a y equals mx plus b. The x is still there, so the m is the slope. It's the number in front. Just the number, not the x. Don't include the x in there. So you have the m, which is -2. I mean, you can tell why I was telling you you're wrong when you said 2, because it's not 2. It's -2. That makes a big difference, right? That means the slope is going down. What is the y-intercept of this line right here?
0.
14.
There we go. 14.
Oh, I see.
It's the b, right? It's the stuff that doesn't have an x in front of it.
Yeah.
All right. So that means I go up to 14. 14, right up there. This is my ugly graph, by the way. 14, and then I go down 2, across 1, down 2, across 1, down 2, across 1. So I'm going to go to about maybe 7. So it's going to cross from here to here. I'm just graphing that line. Are we cool? And it's a very ugly, rudimentary graph, right? I mean, if I wanted to do something really nice, I would pull out graph paper and just hit it. But this is my ugly graph. Are we cool with this? Do you know how to do this? Do you know how to graph a line? Good. Just making sure, because that's on your test as well. What about this guy right here? What is the slope of that dude?
-1/3.
-1/3. What's the y-intercept?
4.
4. Awesome. So I'm going to go up to 4 right about here, okay? And I'm going to go down 3, or wait, down 1, because that's the rise, across 3. So down 1, across 3. So if I'm up at 4 over here. This is 4. I go down 1, and I go across 3. I'll be hanging out here at 3, 3. Does that make sense?
Yep.
And then I'm going to go down 1 across, so I'm at height 2. I go across 3, so I'm at 6, 2. Right. And then I'm going to go down 1 more, and I'm going to go across 3, and I'm here at 9, 1. So this would be kind of my graph of that. Does that make sense to you? We cool? Awesome. So here's my question to you. When I want to solve these two equations, that's what we're asking you to do, simultaneous equations. What I'm really looking for is a point on this graph. And if this is the graph of one line, and this is the graph of the other line, then what do you think that point that I'm looking for is?
Right when it crosses.
There we go. Exactly. When it crosses. Because lines cross each other, right?
Unless they're parallel.
Unless they're parallel, the lines cross each other. Well, sometimes even when they're parallel, lines will cross each other. I know. You're giving me the crazy look. That's what I'm gonna cover today as well. But lines cross each other, and we're cool with that, right? Now, lines could happen to cross each other at right angles, and we call those perpendicular lines. And we know the test to see whether or not they're perpendicular lines. Are these two lines perpendicular? You can take a look at these two equations and tell me right off the bat. Why not?
Because they're not.
Because they're not?
It's not a right angle.
Because the picture shows
It's
you.
not a
But,
right angle.
but without graphing it, can you tell if that's perpendicular? The answer is yes, of course you can. If this is -2, then in order for this to be perpendicular, this would have to be positive 1/2. Because you reciprocate that, and that would be positive 1/2. That's not positive 1/2, that's negative 1/3. So they're not perpendicular to each other. That's your test, that's how you can tell. Without looking at the picture, you can look at that straight up. Like if this were positive 3 up here, then I would say, hey, those are perpendicular to each other by definition. Because their slopes are negative reciprocals of each other. But for the most part, those slopes are just random. One's -2, one's negative 1/3. It's not like I can really compare those two. Or, if they were the same, then I would say, oh, those two lines are parallel. Does that make sense? All right, cool. So this is when two lines cross and they're not perpendicular. They just kind of cross at some random angle, and I want to figure out exactly when they cross. Now, take a guess as to maybe the x-coordinate of where you think they cross.
6.
6. I'll take that guess. I like that. 6. Okay? Do you guys agree with me? I'm glad you didn't say -12. Because if you look at this graph right here, -12 is way over here. Obviously it's not -12. Right? I'm glad you didn't say 20. Because 20 is way out here. And I'm just ballparking this figure right here, and I'm saying, it's about 6. I agree. What about the height? How high do you think?
Probably about 3 or
2.
3 or 2? Alright. Is it 3 or 2?
2.
2?
2.
2? 2? 2, 2? Alright, cool. So why don't we just put that on the side? We're going to put our guess right here. This is 6, 2. That's what we think our answer is going to be. Alright? Now that's the graphical way of solving it, which has its advantages, and I'll show you where those have its great advantages. We cool? Did I lose anybody at this point? You sure? Alright. Now what I'm going to do is the more mathematical way of solving it. And there's 2 ways to do that. One is called substitution. The other one is called addition-subtraction. Alright, substitution and addition subtraction. I'm going to show you both ways. Right now I'm going to show you addition or substitution for now. And then I'm going to show you some else. Alright, let's take a look at this. For the substitution method, why don't I just start with a clean slate here? This is the original problem. We cool? Alright. Now what I'm going to do is I'm going to quickly solve the first problem and figure out what y is equal to. That was pretty simple. I had it up here just on the board. Can you get y all by itself? Let's try it. Y equals?
Equals -2x.
There we go.
Plus 14.
That's it. You just took that 2x, put them on the other side. It was a plus over here, now it's a minus over there. We're good. I'm glad. This is saying that y is equal to this, okay? Now, I erased this part of the graph, but here's what I'm arguing with you, is here's my points where they cross, okay? I'm saying that if they cross at this point, that means the y value of this line has to be the same as the y value of this line. Do you agree? Obviously, if that's where they're touching, then those y's better be the same.
Yeah.
Not only that, but the x's better be the same because they're touching at the same spot. So the x's and the y's should be the same. So here's what I'm going to do. Is I figured out what y is equal to over here. I'm going to rewrite this thing over here. But instead of writing a y, I'm going to write negative 2x plus 14. Because this is saying that I can replace y's with negative 2x plus 14. Does that make sense? Tejas, as much as you can close that door, it would be better because it gets rid of the glare. If you need to get a smaller chair, that might be an option. Unless you like doing the big
Can I move your
executive chair.
stuff onto this chair?
Yeah, of course. Alright. So, let's see. I know this is going to be a long video, and I apologize, but this is an important concept. I want to go through it slowly. And I want you guys to really understand this. Alright. So, I'm going to rewrite this thing as 3 times y, but what is y equal to? That's perfect. Alright. Negative 3 times y, but what is y equal to?
Negative 2x.
Negative 2x plus 14. So basically I said I did 3y, but instead of writing y, I did what y is equal to. Does that make sense?
Yeah.
Okay. Plus x equals 12. I just wrote this thing down, but instead of writing y, I wrote what it's equal to. Are we cool with that? Did I confuse anybody at this point?
Well, I wasn't paying attention because I was getting into
Okay, then I'm going to tell you what we did. Actually, Coco can tell you what we did. What did we do? How did we get this?
We put on the 3 right here, and then we just took negative 2x plus 14 because y equals to this numbers. So we put in parentheses, and then plus x equals 12.
Would you say that maybe we substituted
Yes.
what y was for what it's equal to?
Wait, where'd you get the 3?
So it was
So we just wrote this equation down right here, but instead of writing the y,
Where did the 3 come from?
oh, it was in the original problem.
Oh, okay.
The original problem stated solve that equation, those 2 equations.
Okay. Got
We
it.
substituted, that's what you would say.
Mhm.
Hence the name substitution method. You see where it comes from? Alright. At this point, this is just straight up algebra. And it's not even that hard algebra. I'm going to distribute this 3 into the parentheses. So I have negative 6x plus 14 plus x equals 12. Are we cool with that?
Mhm.
Yeah, you guys good? Because all y'all are wrong. I'm going to distribute the 3 into here. So I need to put the 3 into here and the 3 into here. Don't forget that, please. All right, so 3 times 14, that's what, 42? You guys see why I changed that to 42 and keep it as 14?
Mm-hmm.
Yes, all right, just making sure. Then what I'm going to do is I'm going to make this, I'm going to put the 42 onto the other side. We cool with that? I'm just going to cheat and do that.